and some persons really know what it means. Some persons are just, some people just know the basics or the introductory part of what data analysis is. So in this course, ushering us into the one of the tools we use in data analysis, I want to give you an overview of what data analysis is all about. So in this introductory part, we are going to be covering what data analysis is all about, the types of data, that's structured, unstructured, semi-structured, the difference between categorical and non-categorical data, difference between continuous and discrete data, data analysis process, that's collection, cleaning, analysis, visualization, and then we now have the tools, that is tools overview. That's now you have the advanced Excel, your R, your Python, your SQL, your Power BI, and your Tableau. So now let's come to better understand what data analysis is all about. So this big name, data analysis. So what is it all about? So data analysis is the process of inspecting, cleaning, transforming, and modeling data to extract meaningful information, support decision making, and identifying patterns and what trends. It's a fundamental component of data science, statistics, and what business intelligence. So we've been hearing of the name data analysis, and this is all it has to say up with the vast with how vast, right, the program or the course is. So I'll just leave it. I just want to equate it or try to bring use a real life scenario, right, we all know about, and try to compare it with each other. I think most of us know how we prepare palm oil. If you haven't even seen them, you might have heard, and if you haven't heard, you might have maybe come across people, or you might have come across it through videos on maybe TikTok, YouTube's, and the rest. So we know that when we want to get our palm kernel, right, the seed, we go to the forest, right, to pluck down the palm kernel from the palm kernel tree and bring it down, right? The stage in which you have brought it down to the final stage in which you get your end product, that's the palm oil, it can be classified as data analysis. Because when you get down the palm fruits, not everybody might know like what this is used for, right? So those cleaning stage where you have to bring it out from the bush, you have to peel it out from its shell, right, from the body, cover it for some days so that you can be able to remove it, clean it, sieve it so that the bags will be separated from the main seed, and take it to the mill for what cooking and what processing. All of those things are called the data cleaning. But when we want to talk about that, when we want to talk about it in the real world scenario, they are all called the processes that leads to what the formation of our red oil. So there's nothing much. The big word data cleaning, data preparatory, pre-processing, and all that. These are just the things we do in between the data. They're just the things we find in between the data. Those things we do in between the data, right, that gives us what that meaningful information. So we'll likely say the palm fruits, right, is the raw data. Then the oil we are getting is the information, because when someone sees the oil, the person can donate like, okay, this is oil and this is used for cooking. You can make up something from that oil. So that's what data analysis is, transforming raw data into what meaningful information to support what decision making. So in between the transforming raw data, you have to inspect it, you have to clean it, you have to transform it, and you have to model the data in order to what extract what meaningful information. Are we following? Are we all following? So if you are following, give a thumb. Yes, give a thumbs up in the chat. Oh, okay, that's wonderful. That's great. So now we'll be looking at the key components of data analysis. Number one is the data collection. I talked about you going to harvest your palm fruit, right, from the forest. So that's why when you go to harvest it from the forest, you gather it, right? You gather, if you cut down about, let's say, 100 heads of palm fruit, you have to gather them from wherever you have cut them and place them in one place, in one location. So that's what we call data collection. Gathering data from different sources such as the database, the APIs, the surveys, or the web scraping, right? You gather your data from there wherever they are, put them together, and the next step is to what? Is to clean your data. You know, when you've gathered your kernels, right? Your palm kernels, when you gather them into one place, you begin to clean them, right? You move them out, begin to clean them. That's when you have to break down, you have to remove the main palm kernel from the head, right? You remove it. When you finish removing it, you leave it for a while, you cover it. When you cover it for like 1 day or 2 days, you now have to start separating the chaff, that's the back, from the main seed. You sieve them up. So all of those processes involve what? Cleaning of your what? Or processing your what? There are processes that involve what? Making your crude, your palm oil. So but here in this context, when you talk about data cleaning, it just has to do with removing inconsistencies, right? Data that are inconsistent or are not necessarily important or relevant to the business question you want to answer. You don't talk about handling missing values. So if there are missing values in between the data you have, maybe somebody you are trying to record, maybe there's a record, right, a column containing information of a place or of a country, and probably in row number 10 the column there is missing. So you should be able to spot out missing values, cells that are empty, cells that contain what? Empty what? Values. So you should be able to check for them and look for the appropriate, is either you delete them or look for the appropriate values to fill them with. Number 3 is what? Correcting errors. Like now, probably you get data, it might not be data you got by yourself, it might be third party data, and you check for name spelling. Sometimes name spellings occur either with maybe somebody wants to write root and the person spelled R-U-T instead of R-U-T-H. You need to check for those check for those errors. Number 3 is prepared data for data analysis, checking for your errors, handling missing data, removing inconsistency. Inconsistency could be standardization. Maybe you are having an uppercase mixed with a lowercase in your data. You need to standardize everything to ensure that all of your data are either in upper cases, in lower cases, or in proper. Number 3 is your exploratory data analysis. You guys have heard about this phase, exploratory data analysis, and sometimes it's more confusing than we think, right? So in this stage, this is what really happened. You summarize the data through statistical measures. You will use your mean. I think we are more conversant everybody did mathematics here. So irrespective of you being an art student, a commercial student, or a science student, we did maths, right? And we just did elementary math like your mean, your median, and your variance. And there are other advanced statistical formulas which we'll discuss further, but I don't think we'll be in this free class anyways. So we now talk about visualization using charts and graphs. Examples of charts and graphs: I'll talk about your line graph, talk about your bar, your column, your scatter chart. We talk about your box plot. There are a lot and lots of chart you can use to summarize your data, so that a layman who doesn't really know about what you're talking about can see it and say, oh, okay, this is where we are having deficiency, this is where we are having higher sales in this region, this is where we are having higher diabetes occurrence, this particular age has a higher diabetes occurrence, this particular age suffers less. So this is at this stage you just have to do visualize and use your statistical formulas, functions, and the rest in your exploratory data analysis. That's your EDA. Then talk about data transformation. We then talk about converting data into a suitable format for analysis, such as normalization or aggregations. Let's say normalization, sometimes you would see actually numeric figures, right, where they have inconsistency with the numbers of zeros, or yes, especially numeric numbers. You want to standardize everything, ensuring that all of them, even if it's in row A, and even if it's in column A and column B, you want the numbers of zero to be consistent among each column. So you have to do your normalization, then your aggregations, such as your sum, your mean, your product, like using formulas to aggregate your data. Then you talk about your data modeling. Said applying statistical or machine learning model to predict or derive insight, right? So now this has to do with now in-depth. So for those who are familiar with Power BI, you know how to show relationship, right, using data modeling. For those who are familiar with machine learning, you should know about supervised and non-supervised. Supervised learning, you should know about the regression and the classification. Then unsupervised learning, you should be aware of the anomaly detection, the fraud, the anomaly detection, the fraud detection, anomaly detection for detecting fraud. Then you should know about the dimensional stuff. Okay, I think I forgot now. I'm going to refresh back there. So these are the different types of machine learning prediction you should know about, right? Then we're going to talk about the general visualization, presenting data and insight through charts, graphs, dashboard, or a report to make finding more understandable. Talk about the general visualization. So after you've created your charts, your individual charts and graphs, so in this visualization you have to create a dashboard or a report, right, showing everything you have done and summarizing finding, giving us in your report. You should have your problem statement. You should have the tools you use while drilling the data. You should also have you should also state out the insights you've gotten from the data and the recommendation you are offering to this particular problem. So this is what is contained in your report, and your dashboards are just all about your charts being visualized and all that. So these are the key components of data analysis, and I just hope you all understand that. So importance of data analysis. You've just been hearing data analysis, and some people will be like, what is the main importance of data analysis in every field or every sector of the economy? Because truth be told, there is no place where data analysis is not needed or is not important. Tell me any place and I'll just try to argue with me, and I'll tell you any place. I'll try to tell you why data analysis is important in every field and every sector of the economy. Because every day, every second, data is being gathered, and the need for a data analyst is being required. So that's why in 2025 to 2027, we need to really bridge the gap that is missing in the data world. So we need more data analysts, we need more data scientists, we need more people who can actually drill labeled and unlabeled data. So this is why we are more important and needed in internet, maybe using the platform Facebook, Instagram, and the rest. And you would notice that maybe Facebook ads are not running well. You found a problem. You would notice that Facebook ads are not doing well, and you could say, okay, why is Facebook ad not doing well? Is it that we are not targeting our product to the right audience, or is it that our monthly budget is lower compared to the ones we use on other apps? So in data analysis, you could just spot problems after your general summary and getting insight. After everything, you could spot problems that needs actionable solutions, and you could prefer solutions to it, and it could be a go and a win-win for both you and your stakeholders. So we don't talk about efficiency. We talk about optimizing processes by identifying bottlenecks and resource mismanagement. Here is all about finance. So most times those people in the financial sectors, and I don't think there's any business that don't actually do with buying and selling. Aside health, maybe when you want to work on health data and talking about sickness, you're trying to predict maybe someone has the numbers of people who have diabetes and those that don't have diabetes. But for resource mismanagement, like those in the financial sector, those who are those who are trying to analyze data from the financial sector or anything that has to do with sales and money, right? You could actually spot what the mismanagement and try to tackle everything and profile what more efficient way to do things and to handle money better. So we'll be moving over to the next one. Then we're going to talk about the types of data analysis. We've been hearing types of data analysis, and yeah, I think there are 4 as stated here. So number 1 is the descriptive analysis. Focuses on summarizing historical data. So you should check it. You should see this historical data. So you have data you must have handy must be data that are maybe that are gotten for the last maybe 5 years, 1 year, 6 months, 2 months. So you would summarize that data, right, to check what happened. Someone could just give you a data and say this is data, and maybe I'm experiencing low sales, I'm experiencing this, I'm experiencing that, and it gives you data. It's left for you to check out, to use the data given to you to check out what has really happened and why the person has been experiencing lower sales maybe in the last 1 year. So the tools you can use to do that, you could use your media, your charts and your table, right? So number 2 is your diagnostic analysis. This examines data to understand causes, right? Why did this happen? Your descriptive analysis focuses on what really happened. So now you want to understand why did this happen. If I'm experiencing low sales within the last 6 months, within the last 1 year, why did this happen? So you have to pinpoint the root cause, what made this happen. So this is helping you find the root cause. So most time you could now use your correlation, you could now use your hypothesis testing, right? Your null and your using your hypothesis testing, you could use your ANOVA, your t-test, your z-test to actually find all of this. Then I'll talk about the predictive analysis. Uses data to forecast future outcome, what will happen. Like I made use of the example using our weather forecast, right? I said you could use data from the last 5 years, because when you talk about forecast, we talk about seasonalities. You could use forecast to find trends, to find seasonalities, to find cylindrical variation and random cylindrical elements and random variations. So this is under predictive analysis. So you use the data to find forecast future outcome, what will happen. So if I'm using this data, I'm saying what will happen in this season, what will happen in that season. Since this has been recorded that in the last 5 years we have recorded this particular thing always happening in this season. So let's use the data to forecast next year what is likely to happen in the next season. So these tools you can use here are your regression models, your time series analysis, and the rest. We don't talk about the prescriptive analysis. We all know about the when you go to the doctor, when they diagnose you of a disease and they say, okay, this is what I'm recommending, this is the drugs the doctor has prescribed to you to drink to cure your disease. So it's something like that in this scenario. We don't talk about the prescriptive analysis. That's what recommends action based on analysis. Here you are recommending, okay, this is what should be done, right? This is what you should be done. You can see it here. The tools you can use for it is optimization algorithm and stimulations models. So these are advanced data analysis tools that we all can use. So now let's come to tools and techniques for data analysis. Right, you move down, you now see the programming language, right? Python, you see types of programming language. You see your Python, your R, and your SQL. But we classify SQL as a programming language, because sometimes you are writing a syntax, right? A structured syntax. So mostly what SQL is used for is just for data transformation and extraction, right? So when we talk about the spreadsheets, we talk about the Microsoft Excel, and we talk about our Google Sheet. We all know that. We don't talk about our visualization tools. We talk about our Tableau, our Power BI, and our ggplot2. Our ggplot2 is in our programming, and we'll be learning that in this class. So how to use your ggplot package to plot different kinds of charts. using it to answer a particular question. So when we now talk about the statistical softwares, we have the SAS and we have the SPSS. I really don't know which, if anybody's familiar with the SPSS, but SPSS is a good word, statistical word tool, very simple to use if you can actually find your way across it. No complications like that, right? We want to talk about, we want to move over to the types of what? Data analysis, right? Type of data, sorry. We said data can be classified into three main categories based on its organization and what? Format. We have the structured, we have the unstructured, and we have the what? Semi-structured. Each type has its unique characteristics and what? Applications. So let's drill down to the difference between each of them. So under the structured data is organized in a well-defined schema, right? Schema, often stored in a tabular what format like your row and your what columns. It is easy to analyze using traditional data data analysis method. So when you talk about structured data, you're talking about data in a tabular form that involves what? Rows and columns and cells, right? So these are data in a structured form. So characteristics of this, we have clearly defined fields and data types. We have your integers, your strings, and your dates, right? Typically stores in relational data, that's the SQL, because SQL actually works with relational data, and relational data are stored in what? Tables and rows, while unrelational data are data like reviews from Facebook ads. So those data that cannot fit into what? Rows and what? Columns. So we now said it's highly organized and what? Searchable. So you see that your data are highly organized and searchable. When you're looking for country, you know that this particular column contains all the countries I'm looking for. This particular column contains all the names I'm looking for. This particular rows contains a data item and what? Its values. So examples of structured data, we have our spreadsheets. Examples are in Excel files and your Google Excel files, right? We then talk about the customer information in the CRM. So we have your name, your age, and your email. So customer information in your CRM. Those who have done this CRM courses, customer service courses or so, I think you will learn that too. Then transaction records in database. When you talk about transaction records in database, so it could be maybe sales transaction, it could be any transaction that are being recorded in database. Examples of database you could get, you've seen your Access database, your Oracle, your Mongo database. So these are examples of what database. So those who will be diving into I think is it web programming or so. Those people that use those database to filter things, I think it's web programming, I'm not really sure. So tools for analysis, you use your SQL for querying relational database. You use your Power BI tools, like your BI tools, business intelligence, that's mean your BI, business intelligence tools, like your Tableau or your Power BI. Then programming libraries like your pandas in Python and your dplyr in what? R programming. We are going to be making use of these two in our R. Then now talk about the unstructured data. Unstructured data lacks a predefined format or a schema. So it doesn't have a format. It is not presented in rows and in columns. So making it more challenging to store and analyze. So it's making it more challenging to store and analyze data. It often requires specialized tools and techniques for what? Processing. Characteristics of an unstructured data, we have no clear structure or organization. So it's just randomly written, right? It's not in table, it's not in row. So you cannot even actually differentiate it. So most times people use clustering. In machine learning, for your unsupervised learning, you could use your clustering method to find data with similar groups. You can group data in similar groups, just like in your supervised learning. So unstructured data usually fall under our supervised learning. So we now talk about it requires significant pre-processing to extract insight. So if you are putting 70% in cleaning your data, like in cleaning your data under in cleaning a structured data. Let me just put it that way. So if you require like 70% in cleaning a structured data, you would need like 101% in cleaning an unstructured data. You need accuracy in order to extract insights. So you should just pay attention to this. That's why machine learning is, any person who knows machine learning is a hot cake, right? Their salaries are always very high because you need so much patient time. You need to put in time and ensure that the data is accurate so that you can generate and extract insight. It cannot be directly stored in a relational database. You cannot store that because in relational database can only contain data with table with structures, so they are in columns and rows. So examples of unstructured data, we have your text documents, that's your emails and your PDFs. We have your images and videos, right? You have your social media posts, like I said, your tweets, your comment, your reviews from people, right? When you run an ad, people leave reviews. Then audio files, your podcast and your podcast and your recordings. So these are examples of unstructured data. So tools for analysis, you have the natural learning processing for text analysis. So when you want to analyze for text, like this text document, emails and PDFs, you have to use your natural learning process. That's your NLP. Then we talk about the computer vision for image processing. So when you talk about image, you want to make analysis for structured data under image and videos, you would use your computer vision for image processing. Then you see big tools like the Hadoops and the Apache Spark, right? So these are examples of tools for analysis you can use for unstructured data. So when we now move down to semi-structured data. So this is the combination of both structured and unstructured data. So the semi-structured data is partially organized and contains elements of both structured and unstructured data. It has a loose schema but does not fit neatly into a relational database. So it comprises of both the characteristics of a structure and unstructured data. So it really doesn't fit into a relational database. Characteristics of these are it contains tags, markers or keys to organize the data, more flexible than structured data, but easier to analyze than unstructured data. You can easily analyze this than unstructured data. Often stored in a NoSQL database. So it's often stored in a non-relational database. So examples of these, we now have the JSON and XML files. We have the web server logs. We have the sensor data, and we have the email metadata. So you see your sender, your recipients, and your timestamp. So when you send an email, when you check the email, you see some of the meta information. Those information inside an information is called a metadata. So an information inside an information is called a metadata. So if you take a picture, right, when you take the picture, you see a place where they say properties or more information. So when you click on that part, you see where they say size of your picture, the date it was taken, and all that. So that's a metadata. So it's an information inside the information. So tools for analyzing this, we have the non-SQL database, like I told you, like the MongoDB and the Couchbase. Then tools like Python, that's the JSON and the XML modules. Then we have the big data frame for large scale analysis. So comparison table. So this is if after all the long talk I've just said now, this is just what you could use to compare between the three types of data. So we use the features are the schema, the storage, and the examples, then the ease of analysis. So for structured, we have fixed and predefined under the schema. Unstructured, we have no schema. The semi-structured data, we have flexible, loose, and schema. Then the storage, we have relational database, data lakes, and that is under the unstructured data. We have the data lakes, the cloud. So please, I hope you guys can. So we now talk about the categorical, we talk about the cases where you can use the structured, unstructured, and semi-structured data. Talk about the banking transactions, the employee records, that's for the structured data. We now talk about the unstructured data. We talk about sentiment analysis of social media posts, right? Facial recognition, you would use that for unstructured or unstructured data, where you have to use similar facial recognition to what, to make an analysis, right? Then talk about the semi-structured, where you talk about the API data integration and the IoT data processing. So now we'll move over to the categorical data. I know we've always had categorical data, non-categorical data. Now I want to break them down to the barest minimum I can so we can understand. So categorical data represent variables that classify data into distinct groups or categories. They can be divided into the following types. So categorical data more or less are just like mainly text. So when you hear about categorical data, you just talk about year of text, any data that has to do with writing, like in letters, so they are textual data. So examples under categorical data, we have just the nominal and the ordinal. So the nominal data, look at the explanation there. Categories without no instinct order or what, ranking. Just a normal kind of data. Examples of this data are what? Your name, gender, male and female. Male and female doesn't have ranking. You cannot say female is higher than male or male is higher than female. Talk about blood group. You cannot say blood group A is higher than blood group B, or blood group AB is higher than blood group O. You cannot say color, eye color. You cannot say because I have black eye color, I'm superior or more higher to someone that has a brown eye color, right? You can see your green eye color. So these are examples of what? Nominal data. When you talk about ordinal data, you now talk about categories with meaningful order and ranking. So these are textual data, but they can be ranked. They are ranked, right? But this difference between levels are not what? Uniform. They don't have this uniformity amongst themselves, right? So examples are your educational level. You see your high school, your bachelor's, your master's. So you know that after your high school, you go into what? Bachelor degree, right? After you got your high school certificate, you get your bachelor's degree. After your bachelor's degree, go into your master's. After master's is what? Our PhD, right? Then we talk about customer satisfaction. We now say low, high, medium. So these are what? It has an order of ranking, right? So we now talk about military rank. We now see your private, your sergeant, and your what? Your captain. So these are the examples of nominal data and ordinal data. So your non-nominal data, we have examples of a non-categorical data. So those are mostly numerical data. They are non-categorical data represent variables that are quantitative and what? Measurable. They can be divided into the following types: discrete and what? Continuous what? Data. So examples of discrete data, we have the numeric data that take on specific countable what? Values. So something you can count, right? The examples of what? Discrete data. Examples are numbers of students in the class: 10, 20, 30. Then you can say numbers of cars sold: 1, 2, 3. So we're not talking about the continuous data. He said numeric data that can take on any value within a range, including what? Including decimals. So yeah, when you want to differentiate between discrete data and continuous data, you should just have it in mind that discrete data can be counted, continuous data can be measured. So there are discrete data that are values that can be counted, while your continuous data are values that can be measured, right? And they may include decimals, but your discrete data doesn't include decimal. So it just include whole numbers. So examples of continuous data are height. You can see your height has 5.8 and it can be measured. You see your weight has 10.5 kg and the rest. Your temperature, these are examples of what? Continuous data. So we now have the mixed types of data. Some data sets contain mixed types of categories and non-categorical data. For examples, a data set about customers might include age, right? That's numerical, gender, that is categorical, and income, that's numerical. So a data set, right, could contain the combination of both of them, the categorical and what? The non-categorical data. So these are the key difference between your categorical data and your discrete data. So you could just take a look at it. Possible values, infinite values between range 1.1 to these are continuous values. The discrete values just have finite sets of specific values 1, 2, 3. This can be counted, like I said. This can be measured, right? Data can include decimals and fractions, but these ones are always what? Integers. Graphical representation often visualized using histograms or line graph. You can use histogram to visualize to show the distribution of the graph. You can often visualize using the bar chart or a dot plot. The nature of the data: continuous, flowing, or unbroken. They are always continuous, right? They are discrete, distinct, or what? Separate. So these are just the key difference between the both types of what? Data. So practical distinction, we now go down to practical distinction. We now talk about continuous data. Continuous data captures measurements with precision and what? Variability, right? Variability means distance, right? So it just captures precision and what? Variability. Then examples are measuring a river's depth, right? Depth could which could be 15.345 meters. Then for your discrete data, captures counts or quantities that cannot be subdivided meaningfully. Examples are what? Counting the numbers of books on your shelf, counting the numbers of clothes in your wardrobe, counting the numbers of plates in your house. Examples of discrete data. Continuous data are counting, weighing the amount of gas cylinder. You want to know the amount of the amount your gas cylinder is weighing. You want to know your body measurement, right? You want to know how tall you are, right? So you want to know the particular degree, the particular temperature for a particular day, right? Or a particular substance. You would use what? Your continuous data for that. So let's move down. So we're going to talk about the types of analyzing the data analysis process. The process of data analysis involves 4 key stages, and that's the data collection, the data cleaning, the data analysis, and the word data visualization. Here is an overview of each of the following processes we need to look into, or you'll be looking into as data analyst. So we talk about the data collection. So objective, it gathers relevant and reliable data from various sources to what? Address the problem or a question. So if you are to answer a business question, the first thing you should ask, where are my data stored, so I can go and fetch them out. So the different places where your data are being stored, that means that the data you need to answer that particular question, you go and get it from wherever data is stored and bring it and merge them together so you can use them to answer your question. So steps: identify the data source. Is it an internal data or an external data? Internal data could be company database. You work for a particular company, like I work for Nestle company, and I want to analyze Nestle data to find out maybe the highest product where we made was the highest sale. I could say, okay, I need to go to the sales department and request for that data set, or I can go to the CRM system and also request for the data set. Then talk about the external data set. We now talk about the HPIs, the surveys, and the public data set. So public data set, we now talk about those you find on Kaggle, those you find on the WHO website, those you find on earth.gov, those you find on different platforms. What your public data set. Your surveys could be your questionnaires and the rest, and the API, which also find it online too. Then you say collect data. Use tools like web scraping, database queries, and manual entry. So the web scraping, there's this app without the instant data scraping. I don't know whether any of you know about it. So you could just go on Google, just search for instant data scraping. So when you do that, you can you just pin it to your Google Chrome, and it helps you scrape data from any source. If there's any available data there, it scrapes it out and gives it to you. So you could go and check it out. Then we now talk about the data queries, your SQL. So that's where you store data. So you can query data from that particular database. Then your manual entry, So those who work in as a sales representative, so you want to enter manually the sales you guys have made, maybe you enter it manually, so you could go there and say, okay, this is it. I maybe you wrote it on a book. You could manually enter it into your spreadsheet package or whatever database you are using. Then validate data. Check for data consistency and completeness. Ensure that your data is consistent across all region, and check that it is complete. So every data you need to answer that question is complete. No data should be missing, so you can actually get your analysis very correctly. So tools to use, you use your API. That's the examples are the Postman and the CURL. Your databases could be MySQL or PostgreSQL. Your web scraping could be Beautiful Soup or Selenium. Your surveys could be Google Forms and data types. So those who have seen Google Forms before, so those are what you could use and collect data and do a lot of things. So talk about your data cleaning. The objective of this is just prepare raw data by correcting errors, ensuring inconsistency to make it suitable for what data analysis, right? So examples here just involves cleaning the old data so you can extract what information. That's just the essence of data cleaning. You take raw data, clean it, and remove all the inconsistency, your errors, your unwanted columns, and standardize everything just to what extract what to get out what your meaningful information, your meaningful insights. So steps is what undo missing values, that's your imputations, mean mode or removal of incomplete rows and columns. Number 2 is correct data types. Ensure that numeric, categorical, and data variables are properly defined. So each column should contain one type of data type. Each column should contain one type of data type. They should not be mixed types of data type in one column. So you now take about remove or duplicate, identify and eliminate redundant rows. So any row that has duplicate should be removed, and check for non-aggregate columns like your okay. So it will be the class will be ending now because it's already more of them you could use to detect outliers. So we now talk about tools you can use. You can use your R, your tidyverse. Under the tidyverse package, you see your dplyr, that's the library. You see your janitor. You can also use it to summarize your data. Then talk about the Python programming you see your pandas and your numpy. Talk about your Excel, you see your filter and your sorting options in Excel. So we move down to data analysis. Objective, extract meaningful insights, patterns and relationship from a clean data. So when you have cleaned your data, you filtered everything, you've extracted your meaningful insight, that's the information, then you will now come here and perform your main data analysis. That you either perform a descriptive analysis, you either conduct a exploratory data analysis, or you apply inferential statistics. So examples of the data of the descriptive analysis are use summary statistics like your mean, your media, and your mode. Then you conduct exploratory data analysis. You could use identify trends using your line chart and the rest, correlation using your scatter chart, and distribution using your histogram to check all of those. Then talk about inferential statistics. We then talk about the hypothesis testing. You talk about your regression, checking for causation. Talk about your predictive modeling, trying to find out what will happen, right? Using predictive models or predictive functions and the rest for your data analysis. So tools you can use for this, you can use your Python, your Spicy, your Scipy, your stat modes, your stat models is for statistics, your XLearn is for also your statistics too. Then you now talk about your R, talk about your base. So these base are actually the package that already by default in your system. You talk about your Carat. This is just for visualization. This is just for machine learning. The Carat is for machine learning most of the time. Then the Forecast, you use it also for machine learning, for forecasting. So you talk about your SQL, talk about the aggregations and the joins for summarizing data. So you use your count, your sum, your product. You use your conditional formatting tools like your if, you use your logical arithmetics like your if and or, your joins like your inner, your outer, and those different kinds of join you use to summarize the data under SQL. So these are the various tools you'll be using. Then we talk about data visualization, right? Objective is what? Presenting findings in an intuitive and visually appealing way to support decision making. So when you know, some people are attracted to colors and find things. So most, I want to say this, the main importance of a visualization is not the fine chart or how well or how beautifully stated your chart is, or your dashboard is. The most important thing in data analysis as a whole, right, when you're analyzing your data, you should ensure that you answer what? The underlining question. Ensure that what you are visualizing, right, answers the question at ground, right? So even if you visualize everything and you have a very beautiful chart, but yet you are not still able to tackle the question or to answer that particular question, your chart is just like rubbish. You have just done irrelevant nonsense chart. But so when you are creating a chart, right, or a report, there are rules you need to follow, right, to create a very visually appealing looking dashboard. Not too much color, one or two colors are okay. Not too much labels, right, blinking everywhere and the rest. So there are rules you need to follow to create a very lovely visualizing chart. So we're not talking about design advanced visualization like your heat maps, your tree map, your network graphs for complex data. So I think if you are following me on TikTok or on LinkedIn, you'd see when I created a heat map to just show distribution of some things to help you check hierarchies. Which of these states has more sales? Just help you to show hierarchies and show comparisons of sales or any other thing, just to find which one has the highest and which one has the least. So we talk about building dashboard, interactive tools to communicate finding dynamically. So your dashboard comprises of all your charts, right? Each tiles has a chart inside of it. So this is what called your dashboard. So tools you can use is your Matplotlib, your Seaborn, your Plotly for Python. For R, you would use your ggplot2, your Shiny. Then for Power BI, you use for your business intelligence tools, you use your Tableau and your Power BI. Then for your Excel, you use your Power Tables, your pivot tables, and your charts. So that what you'll be using in Excel. So this is how the workflow diagram looks like. You collect, right, from wherever source you've kept your data, you collect it, you clean it, you analyze it, then you visualize all of it. So example scenario of how to implement all of this. So analyzing, goal is to analyze sales performance across region. So in your database, probably you have your sales column and you have your region column. So what you are going to do is to first import sales data. So wherever your sales data is in your company's, wherever your company stored your sales data, you have to import it from the company database or the CMR. You clean it, remove duplicates and handling missing values in the sales column. Number 3 analysis is to calculate total sales by region. Identify top performing regions. So you have to check the top performing regions. You can use you can use heat map to actually do this. You can use bar chart, you can use what are they calling it? You can use bar chart, and you can also use column chart to perform this too. Then visualization, create a heat map to show, you can see the visualization to show regional sales trend, or a bar chart for monthly sales. So this is how you can actually do what you can do. So we'll be talking about, let me see where is any other person to admit inside. We have like 6. So we'll be talking about the overview of popular tools for data analysis. So each tool has unique strengths and is used for specific tasks within data analysis process. Below is a detailed overview of Excel, R, Python, SQL, that's the structured query language, the Power BI, the Tableau, highlighting their capabilities, using cases and their advantages. So these are the popular tools that are used in data analysis. So we talk about the Microsoft Excel. Description is a widely used spreadsheet tool, ideal for small scale data analysis and quick visualization. So if you just have small data you want to visualize or analyze, you could use your Microsoft Excel. So even though Microsoft Excel is the most in demand, like say you can use it in any sector you are working with. So if you know Microsoft Excel is a top title for you, right? So if you are using Microsoft Excel, you just need to just populate is just small data. So if you have data as much as 1 million data, you cannot use Microsoft Excel for it. So there are data that have as there are data that are much as 1 million data sets, right? So you just have to use Python and the other R programming. But for Microsoft Excel, you just has small. You just have to use the data, right? You have to use data set that has what small data, so you can use to visualize. These are the capabilities of what Microsoft Excel can do for you. Data organization is in rows and in columns, basic to advanced mathematical and what statistical functions. Built-in charts, right? They have built-in charts. They have the pivot table for summarizing data, conditional formatting for quick insights. So use cases, we have quick calculation and summaries, budget tracking and financial analysis. For those who want to go into financial analysis or want to major in the financial sector as data analysis, you could also use, they have inbuilt financial tools, even engineering tools and the rest in Excel. So reporting for non-technical users too. So if we don't have those, maybe secretaries, those in the non-technical department like our secretaries, like our public visual assistants and the rest, so all of them use what Microsoft Excel. So we talk about advantage: user-friendly interface. Everybody knows that it's always user-friendly. Extensive formula library. It has a more extensive formula library. Easily integrates with other Microsoft Words too. So you can integrate it. You can integrate it with Word. You can integrate it with what with the PowerPoint. You can integrate it with Outlook, so whatever, you can just use to integrate with other Microsoft tools. So limitations of this: not suitable for large data set, like I said, so you cannot use for large data set. Limited automation capabilities compared to programming tools. So there are a lot of things you can do on programming languages you cannot do using Excel. So we talk about the R, and for the this is the main reason why we are here for the class, right? So this is the R, a programming language and environment specifically designed for statistical computing and data visualization. So these are capabilities. What can R really do for us, right? Let's just look at it. Statistical modeling, like your linear regression, your hypothesis testing using your chi-square, using your z-square, your t-square, ANOVA, and the rest. Talk about the advanced data manipulation with dplyr and the tidyr. Talk about the high quality customizable visualization with what the ggplot too. So you can actually write a syntax, a structured syntax, or to create either a bar chart, a scatter chart, a linear regression. You could create a lot of charts, right, using your ggplot, your package ggplot, to create different kinds of charts, unlike Excel where you just have to go there, touch it, and everything just formulates by itself. But in this you have to write the syntax, and they must be correctly written and correctly done in a well-structured manner. If not, you'll be getting error to not even produce anything. So specialized libraries for machine learning, time series, and spatial data, spatial data and geographical data. So when I talk about use cases: academic research and statistical analysis. So if we have those still in the higher institute trying to defend their thesis and the rest, I think this is a very big opportunity for you to learn these. Others talk about creating publication ready visualization. So like I said, you need to write a syntax for you to create a very beautiful visualization. So if you go to my page on TikTok or on LinkedIn, you'd see where I worked with R programming and created a visualization. So a very sweet visualization. Data wrangling and machine learning experience. When you talk about data wrangling, it's the same thing as data pre-processing. It's the same thing as data cleaning. All the language is the same thing. So when you hear of data wrangling, you hear of data cleaning. Then machine learning experience. So those are who want to dive into data analysis better for higher pay and for advancement in career. You learn machine learning with me. I also teach that, for that will be for a fee, but this one is free for our programming. So let's say limitations. steeper learning curves for beginners. So you just have a steeper if you are not too good in it. If you don't practice well, you will forget it, right? So you need to consistently practice to get it. So that's why I say it's a steeper learning curve for what? For beginners. Slower performance with larger data. So if you have too many data, right, you will not be able to actually so much with it. So we now talk about the Python, right? The baba of everything. It says a versatile general purpose programming language, full libraries. You would see that is a powerful library for data analysis and machine
Hello, Felicity.
learning. Yeah,
I'm sorry, we can't see your screen. Please do zoom in on your screen, please.
you can't see my screen.
Yes, we can't see it
Yeah, I
properly.
cannot see
We
my
can't see the
screen.
document.
You cannot see the document.
Yes.
Okay, okay, okay.
Yes, ma'am.
Oh, okay. Better now. Better.
Oh, yes, it's
Yeah,
better.
yeah.
Okay. So we talk about the
So can
Thank
see.
you.
Python. Okay, no problem. We talk about the Python, right? This is a versatile general purpose programming language with powerful libraries for data analysis and machine learning. So you know that it's not only data analysis that use Python. You would see our programmers, our web developers, and the rest. So it's just a powerful tool that comprises of very powerful libraries in it. So capabilities, we have data manipulations with Panda and NumPy. We have data violation using the matplotlib, the seaborn, and the plotty, right? The seaborn enables you what get a very final and more modern word visualization, unlike the matplotlibs, right? Then this plotty used to just plot graphs and the rest. So machine learning, use the skit learning, use the TensorFlow, and use the PyTorch. I think I posted something on Python on my TikTok, and somebody was asking me what's TensorFlow, and I was like, it's one of the libraries in Python, and it was finding it difficult to grasp and the rest. So I think so you can see it here. So it said big data processing with DAX and what? The Spark. So you could process larger data using what each of these libraries then. So use cases. So data cleaning and preposition, predictive modeling and machine learning, automation of repetitive what taxes. I know somebody have heard of macros. If you have heard of macros, you have done something similar to macros, or you have heard or you have seen. So I think this is where it plays the role, automation of what? Repetitive taxes. So we talk about the advantages. We talk about widely used across industries. So I don't think there's no industry. Like, is there any industry that don't use Python, right? Because it's so good, right? And it's so vast, and it has a lot of libraries. It has a lot of packages installed in it that it's mostly needed by even techies and non-technical people. Is that non-tech? No, just techies. I don't think non-technical people use, just techies, sorry. So seamless integration with webs and cloud technology. Those who do in-depth of web programming and the rest should know about this. I don't know much about that. Rich ecosystem of libraries. So like I said, it has so many rich libraries you can use to manipulate data, manipulate apps and the rest. So this actually has it. Limitations can be slower than specialized tools for statistical taxes. So most times when you are using Python for um, statistical taxes, it might be slower than a tool just made or designed for statistical tax. You know it will be faster because Python is just how it does different things and might be slower when it comes to statistical word applications. So it requires programming language. So if you don't know Python, if you don't know programming language, my dear, is a no-no for you. But if you are willing to learn and grow at this pace, you would actually kick in and learn very fast. So we now have the SQL, we have the structured query language. So the description, a language used to manage and query relational database efficiently. So this one too, you have to follow a syntax, like just like you are writing codes in R programming and you are writing in Python. So you just have to follow just a correct written structured syntax. So capabilities, data retrieval, filtering and aggregation. Aggregation means addition, subtraction, count, applications of all those small functions. So we talk about joins for combination of data from different multiple tables. So if you have multiple tables, you will use your join. And we all know, all of us have done structured query language, you know, you would have seen the use of, even if you have not done it, if you are in a community, or you have scrolled through um, um, LinkedIn, watch videos on TikTok or YouTube, you would have seen something like inner join, outer join, join, and the rest. Different kinds of joins, right? To just link in multiple tables and match in what unique word identifiers like your IDs. So data transformation within database. So you can transform data within database. So database is like, is, how would I put it? It's like a house housing different tables, right? It's like a house built, like you are rearing chicken. So if you build a chicken house, that house is the house rearing the other chicken. So that's how database is all about. So use cases, extracting data for analysis. So if you want to extract a particular data for analysis, and you can actually create temporary tables using SQL. So that's the beautiful thing about it. So you can extract data for analysis. Number two, data management in relational databases. So you can manage data, right, in relational database. So real-time querying for business operations. So you query data to get what meaningful insight. So even if you want to sort, you want to filter, you want to extract, you want to perform different things, right, you can just query a particular data and what get it out. So advantages of these, you have optimized for handling large data sets, right? If you have large data set, you could use it. Essential for working with database systems. So examples of database system, you see your Access, you see your Oracle, you see different kind of database systems that we have. Your Google BigQuery is a database system you could use to answer. They say easily integrates with tools like Excel, Python, and R. So when you finish extracting and cleaning your data in SQL, you could easily connect it to, upload your data to Excel, Python, and R, and use it to create wonderful visualizations and what apply statistical functions to your data set. So what you've cleaned. So limitations, not suitable for advanced analysis or machine learning tasks. Like I said, it's just for querying and filtering your data. You can't use it to perform statistical analysis. When you want to perform statistical analysis, you have to either go to Excel or you have to go to your programming languages to perform statistical analysis or machine tasks, right? Limited visualization capacity. I really don't think SQL has a visualization capacity, unless they've upgraded the feature in SQL. But as for now, I don't think there's any visualization. So if you want to do any visualization, you either have to go to Excel, your BI, that's your business intelligence tools like your Power BI and Tableau, or you can go to your programming tools like your R programming and your Python, right, to create visualization. So the last but not the least, okay, we have table is the list here, or I call it a day. We now have the Power BI. It's a business intelligence tool for creating interactive dashboards and reports. So capabilities for this is importing data from various sources. So you can import data from you can even import data live. You can get live data from the web and analyze it with Power BI. So creating dynamic visualizations and dashboard. So because if you, like what I said, you can get data directly from the web. When you get data directly from the web, it's not stored in your Power BI as data set, not being downloaded. So any update on that data on the web is being updated on your any dashboard or any charts or any graphs you've created. So we talk about creating dynamic visualization and dashboard. So any visualization you want to do, there are so many visualization like cards, tables, matrix, donuts, different things on Power BI, different visualization charts you can use, right? Then you can also create dashboards with it. Real-time analytics and automatic updates. So there are a lot of updates you can do with Power BI. Use cases, enterprise level reporting, real-time business monitoring, collaborative sharing of insights. So if you want to share or collaborate with different people, you want people to have access to a particular dashboard, you can use Power BI. So if you created something and you want your stakeholder, your manager, you want workers, you want your senior manager to have access to the charts you've created, but with some limitations to various levels of authority, you can create it on your Power BI. So let's talk about the advantages. Drag and drop interface. You have the drag and drop interface, integration with Microsoft ecosystem, so you can integrate it to other of your Microsoft apps, highly interactive dashboard. So you could create, you see all those beautiful dashboard you see, or you just go on Twitter, you scroll and say, how was this dashboard created? There are, most of them are the work of what? Power BI and Tableau, right? So limitations, it requires a subscription for full features. So if you not subscribe, if you are using the free feature, you will not be able to use some of the features there. So less flexible than coding based tools. So you don't need to write any coding except DAX. So DAX is just like a similar way, like a similar something close to X and query languages, right? Your SQL, but you still have to write something, some syntax, right, to it, but it's not as difficult or not as difficult or complicated like R programming and Python. So talk about the Tableau, and this will bring us to the end of this. And in our next class, we'll be entering R programming properly. So for those who don't know, who haven't downloaded R, so I think we'll be doing a more practical class on how you can download R and install it into your system and try to go about the interface, right? So the Tableau, a powerful data visualization tool known for its interactivity and ease of use. Capability, building advanced visualization like tree map, heat map, and scattered plot. So there's a possibility to create a tree map, a heat map, and a scatter plot in Tableau, connecting to multiple data sources. So you can connect to multiple data sources. Storytelling is an interactive dashboard. So there's a place where you can tell stories. You see a dashboard, you see a report, you see dashboard, you now see a report sheet on a Tableau interface. So use cases, visualizing complex data. So if you want to visualize complex data, you can actually go for Tableau. Create executive level dashboard. You can also use Tableau to do so. So let's see. Okay, exploring trends and patterns visually. So if you want to visually explore trends and patterns, you can use Tableau to do that. So advantages: intuitive drag and drop functionality, just like our Power BI. Supports wide range of data source, right? More than the Power BI. Strong community and online resources. So if you want to grow, they have a very strong community. Power BI too has a very strong community, because in between Power BI and Tableau, both are important, but I think Power BI is more in demand, right? Used by most organizations than Tableau. So stronger community and online resources. Tableau too has stronger community and online resources. So there are limitations: high licensing cost. So for you to access more of the features, you still have to pay for licensing or subscription. So limited statistical and machine learning functionalities, it's the same thing as Power BI, because it's a visualization tool and not a statistical or machine learning tool, right? So you can see tools for comparison. When you talk about features, we talk about ease of use. You see Excel, very easy, anybody can learn it. R is moderate, you can learn. Moderate. Power BI easy, Tableau easy. Data handling, small. Excel will just handle small. R will handle large. Python will handle large. SQL will handle large. Then the rest will handle moderate. For visualization, Excel will just do basics for you. R will do advanced. Python will do advanced. SQL will do just basics. Power BI will do advanced, and Tableau will do advanced. For machine learning, Excel is a no. R is a yes. Python is a yes. SQL is a no. Power BI is limited if you are paid, maybe paid for that subscription. Tableau is limited too. For the cost, Excel is low. It's not like it's free. Excel is low. Some people have the cracked version of Excel, so you could just carry instead of paying for subscription to Microsoft. R is free. Python is free. You can use the Anaconda. You can use the Python app itself. That is the PIP. Then the SQL is free, right? Just download and install it and use it. You could use the Google Sandbox. For me, when I'm teaching my students, I use the Google Sandbox. Some people use the SQLite and the rest, right? So Power BI subscription, when you want to use the advanced feature, you need to subscribe, unless you just have to use the normal free feature. Then you talk about Tableau, it's expensive, unless you have money to pay for it and use it for your organization, right, to analyze data. And we've come to the end of the introductory part to data analysis, and in our next class will become entering introduction to R programming, the overview of R programming and how to install and how to install and how then the different interface where you